Hey everyone, welcome to the July 29th, 2025 SIG Node meeting. So first up, we just have an announcement from the leads. We're working on putting together the node highlights for the release. So if you have any suggestions on things to mention or call out for the release, please put them in that document. We'd love your help. Okay, that's that. Next up, we have Alima.
Hey,
Talking
good
about
morning,
the good
everyone.
pod start slide. Hey,
Yeah, so I brought up
are you gonna want to present anything?
no, just the link on the doc is all.
Okay, thank you.
Yeah.
Take it away.
Yeah, I was just bringing this issue up before. I mentioned it, I think like a month and a half ago, that this SLI that's used to measure pod starter latency, it doesn't match up with the documentation, specifically on two fronts. Incorrectly includes in a container runtime and incorrectly includes stateful pods. I just brought up the discussion before, but now the fix is actually implemented and validated, so just looking some reviews on that bug fix.
Great, sounds good. We'll take a look.
Thank you so much.
Thank you. There's nothing else on this one. We have Dikshita.
Hi. So I wanted to bring this discussion up because we did not have a conclusion, but yeah, I think we finally got a conclusion around it, but just a heads up. So right now I have an extension exception for pod level resources beta. The last change that was pending was to add an event in the resource managers such that the error or there can be a log message propped up to the user so that they know that these resource managers are not supported with pod level resources. In the PR that was already created, there were some other changes as well. And then Francesco, Tim, and I were having discussions like individually one on one. And then Francesco mentioned that if there is something in a KEP that we have committed to, like in the KEP, we had committed that we will prop up this error message in beta and it wouldn't just be documented. So yeah, there were some discussions around it whether we just want to skip the support for this feature without propping up the error message versus propping up the log message for the users. So is there any cadence around it for previous features that we have supported in SIG Node? Like if there is a new feature that we are introducing, do we add support for all the features? And if we are not adding support for all the existing features, do we make sure that there is enough information provided to the user from the code itself that that feature is not supported, or just adding in the documentation saying that this is not supported is enough? Yeah, I think that's the question.
Yeah, I would say ideally we would have something programmatic to let the user know. Documentation is often not really well reviewed, and people get hit with gotchas and stuff. So I think anything we can do to let the user know would be better, but I don't necessarily think it's a hard requirement. We can work around some of these things with documentation, but like that, I would say is a last resort if it's not programmatically possible. I don't know what other people think.
So when you say it's not a hard requirement, are you saying that for any stage, like at least alpha and beta stage?
Yeah, I mean, I would say probably at GA stage, we would expect these things to either work together or be programmatically not, working together for a very good reason. But yeah, I think it would be okay to go to beta, but would not be good to go to GA.
Yeah,
In
that's
that
for
case.
sure. Yeah. And the current state right now is we are trying to get that PR in. Like Francesco himself created another PR to help with it. And we are trying to get the PR in, which props up the log message to the users. But if we are not able to get it in today, are we okay doing beta without it? Although I also do not want that. And I'll be trying my best that that PR goes in. Yeah, I already see hands. Kevin.
Yeah, I just, as a reminder for that production readiness, was asking that like between the jump from beta to GA should really be just a feature gate. So like I'd get a little nervous about us saying like features will be added in beta. Like when I was doing the PR reviews, we would,
Yeah.
like if you want this functionality in for the feature, I think we should try to get it in as early as possible. Now,
Yeah.
Sorry, go on.
So we will do another beta for sure in the next release. The problem is I don't want to be blocked on this. Like, but I said that although I'm going to try to see that that PR goes in, but if it doesn't happen, is it okay? Because we'll definitely do another beta. The idea is we want to get enough signals from users today, and hence we want to do at least one, the first beta, which can be used by people and we can get feedback on. But we won't make this change in GA for sure. We will do another beta in the next release, which is 135. Does that does that answer your concern?
I mean, I think the general gist of that policy was to not really have like I don't want what we had happen with swap where we kind of have like multiple stages of betas. Like it gets a little confusing to follow. So I don't know. I mean, I am not involved in the feature, so I don't know how important like resource managers like has to be like I would not like to me it'd be nice to graduate a feature and then say this is a gap, let's have a follow-up cap and then iterate on that one. I don't know if like that was kind of like the idea was that we should try and get these features through and make their feature complete when we promote them to beta. Like the idea of that policy was just saying that functionality should be there when the feature gate is turned on, and we really shouldn't be adding more features in beta.
So right now, in the current KEP stage, it has already been approved that we write another KEP to support these resource managers with pod level resources. So I think that has been agreed upon. The only concern right now is this PR, which sends the appropriate message, which logs the appropriate message in kubelet logs saying that this feature is not supported with pod level resources in beta. And the topology manager and all these resource manager support will come in the other KEP. That has been agreed upon. The only question right now is if it's okay to not throw this error message explicitly and just document it saying that these resource managers are not supported today.
Sorry, Tim's hand up, but I agree with Peter that like if there is functionality that's not supported, it's best to kind of have that as an error rather than relying on documentation. So like I don't know the validation or like if someone has CPU manager and this feature set, I almost think it could be a validation issue that like people would know right off the bat that doesn't work. And then we can relax that like once we have a more designated feature for it.
So if we have this in the validation, I think that would be more painful because the validation error would come from API server. Right now, we are trying to have that lock message prop up in the kubelet instead of having it in the validation. But I'll let Tim go after this. Tim.
I think there's two different things that are happening in the PR. One is kind of figuring out how to surface this message to the user, but the other is actually preventing the static policies from allocating if pod level resources are used. And so that's the piece that I think absolutely must be in before this goes to beta. Because if we tried to change that in a second beta, that would be sort of breaking functionality if a user was already using that piece. Personally, I'm okay with documentation for this. I think the log approach in the latest PR is preferable and isn't much of a stretch from blocking allocating in the first place. On the question of validation errors, I was wondering if surfacing this through the API warnings method or mechanism would be useful, but I don't think we have, we don't know if static policies are being used at API time, especially because that would happen before it would happen before scheduling. So I don't think there's really any way we can use the API warnings method for it.
Francesco?
Hello. Yeah, so I commented in the PR and we had a conversation with Dixida in the past couple hours. So basically, I am fine narrowing down to the bare minimum the existing PR, which, like Tim mentioned, is doing two things: is preventing the actual allocation and surfacing the error, surfacing the fact that allocation has been skipped. The surfacing itself through events, which is also pulling the most concerning is a strong word, but still concerning changes can be removed. But the prevention of the functionality to engage, I agree, and I actually wrote independently that we should have it because we can. I believe it's really a disservice to the users to change it afterwards. So I am fully supportive of having a very minimal change, and in my opinion, ignoring the allocation at container level with a log is already debatable in the sense that it will be probably best to fail admission, even though it carries its own share of problems. So in theory, I think it would be even better, but in practice, I'm okay with the current approach. Well, I mean, with the very latest approach we're discussing, so preventing the allocation and logging at least. And this is where I am at the moment. I'm open for conversation, but I think there is already a consensus forming here.
Yeah, I think so. There is a consensus around it. So I'll quickly summarize. Please let me know if there are any concerns. So I have 5 to 6 hours to debug the tests on the PR that Francesco has created. The PR just bare minimum props up the log messages to users saying that these features are not supported, and we'll try to get this PR in. Otherwise, it's a beta blocker. And we are not able to catch this in the API server validation logic because these are kubelet features and we do not know in the scheduler and in the API server time, the validation time, whether these are enabled and what policies are applied. So it still makes sense to have this logic in the kubelet, and we'll try to get the PR in. Yeah, does anyone have any concerns? All right, sounds good. I already have the documentation changes out as well, because today is the deadline, and I'll get those reviewed as well. Thank you.
Great, thank you. All right, next up we have, I don't know who this is.
It's me.
Lachlan?
This is Cyprian.
Hi.
Yeah. Hey,
Welcome.
nice to meet you. Thank you. Okay, I am one of the maintainers of KOps, the installer that installs Kubernetes for many tests in this org, and installer used by many people. We're using static pods to bootstrap our cluster and basically our nodes. And we're noticing that the static pods go into crash loop back off while waiting for various things to start. So they wait for each other. etcd is API server waits for etcd, other components wait for API server, and in the end, there are cases where due to cloud provider flakes or things like that, it takes very, very long to have a cluster up and running, or the tests failed. So I was wondering if a PR that was submitted in the past to reduce the crash loop backoff max interval for static pods would be considered in this situation. And also, I saw that these days there is a cap and an alpha feature to have a tunable crash loop backoff max, but that one is unfortunately applicable to both static pods and regular pods. So not exactly sure if, I mean, it would be very helpful for control plane, but not sure if I would want to do it for regular nodes. Okay, cool. That was it. Tim?
I don't think I see Laura or Hank on the call who have been working on the crash loop backoff feature, so I can take this. Yeah, I think we still want to, there's sort of two separate features. I think they were combined into one cap. I can't remember if Laura separated them out into two separate caps, but yeah, as you already mentioned, there's the configurable crash loop backoff piece, and then there's the separate piece of changing the global defaults for how crash loop backoff works. We definitely still want to progress with both of those. They've kind of stalled out for a couple of releases, but we do want to pick those back up and make some progress there. I don't know the exact timeline on that. But the other thing that I would mention for what sounds like your specific use case, you could use an init container that checks for the required state and doesn't proceed until those requirements are met.
Yes, we discussed this possibility. I agree that it's a possibility, but wanted to not add another piece of software in the mix, or to put another container image that we have to build and maintain over time. So just making it shorter for static pods, which I guess everybody uses for Bootstrap. I don't think anybody wants static pods to wait 5 minutes to be restarted.
Yeah, so I think in that case, yeah, the answer is we do want to proceed with both of those features, but I don't know the exact timeline on that.
I referenced the PR. So would you want to have tunable static crash loop backoff max for static pods, or you're open to changing the default for it as it's in the pod, the default, the value that it's right now? Splitting it and change. Yeah, sure.
Tim, go ahead if you want.
I was just going to say I'll need to think about this a little more. I'm not really comfortable with the idea of using a separate backoff for static pods. I think in general, anywhere that we are treating static pods differently, like we want to avoid that.
Yeah, I also not comfortable just separate off the static pod from the regular pod, but I do think about the we are going to proceed what we planned, right? The default one you I can see that you are a lot comfortable in your product environment. The default value set to really low and impact all those static pod and also regular pod. But I do think about in your particular use cases, you mentioned that actually could be that node have the special configuration because your control plane node actually could be configured with the lower value and then help your static pod because my understand, of course, the static pod could be on your non-control plane node. Right? So it just depends on how you configure your system. But really you care, actually it is the control plane, like API server, etcd. So I think it's the kind of plan it is per node also can like the customize, right? So that's why I think that's still help in your cases. I just want to, if you know.
Yes, definitely. Thank you. That's all from me. Thank you.
Thank you for this. And also we prioritize this, the work.
Thanks. Let me know if I can do anything to help with that.
All right, thank you. Last up, it seems we have AJ.
Hi, I wanted to start circulating the idea of the swap awareness API that we committed for taking immediately after the limited swap. Could you? I just added my initial thoughts on this document that I just thought to start discussion today. Could you share me permissions? I could share it to go with.
All right, there you go. All right.
All right.
Filter.
Okay. So this document is not finally, there are still pieces I'm working on, but I mainly wanted to focus on the API shape and the behaviors of various modes that we have been discussing on the previous skips. So wanted to quickly gather thoughts on that and see how we could, how we are thinking about swap, API for swap. My first proposal is to have the API managed swap as a separate behavior to not conflict with the existing mode, the limited swap mode that we offer today. Prime reason is that we had many restrictions on what is allowed and what is not. For example, what is criticality of the workload, whether they can use swap or not. For example, guaranteed swap were not allowed to work with swap in the limited swap mode, but this has been requested by some of the users on the swap Slack threads. For example, use cases like CPU policy can benefit if guaranteed pods also can be configurable for swap. And the second reason is that we were not overcommitting on limited swap and making an API allowed swap coexisting with behavior that calculates for a limited commitment on the swap has a lot of conflicts. We would want to avoid that. So my first proposal here is to separate behavior for API based swap. In my thinking, users would not want both API based enablement and allowing node to pick whatever swap as needed or as rationed for workloads. I think that these are two different types of users and they could work with either of the modes as they seem fitting for their use cases. However, this doesn't restrict the other. Kubernetes shouldn't be restricting node groups having one set of mode and another set of mode in the cluster. This can be like a if, for example, a migration story or somewhere like a coexistence story is still possible using taints or labels as we discussed earlier. So this is still possible. My first point to discuss is that there is no restriction, but there will be a separate mode for API behavior. And second aspect I see is the model the resource modeling for swap is not request based. It's more on limit. It basically sets how much swap utilization can be possible on that container. We have discussed this before. That's another point that I want to discuss and gather thoughts here, whether it should be at pod level or container level. In my opinion, a policy whether workload should be disabled for a workload or not fits more on a pod level, but limiting seems more container specific to me. And it also starting it as container enable us to like extend it in the future if need for a pod level resource. Reasoning are these two conflicts that we can avoid. If needed, we can extend this to pod level resource, but currently pod level resource handles, for example, copying, limit as request if unspecified for admission time and things like that. This can be avoided. Container is kernel sees the containers as processes, and that's how the swap utilization is handled. I think that like inherently Kubernetes could start focusing on that aspect. But again, this is what I want to mainly discuss on today, along with the swap limit semantics for various configurations and modes today. Let me quickly go over this on how I see the various use cases. First is when no explicit swap limit is set. This is the majority use cases. We see that like existing pods or workloads when available on the cluster, and when new nodes with workload controlled swap joins the cluster, how would they behave, right? So when this is like a new cluster where there is like no limited swap nodes, this mostly just align with the no swap behavior. Only when there is like, if it's an existing limited swap user, then there is a conflict arises because there is no calculation of limit. This conflict can be avoided by working with taints and labeling for node selection as we see it. So I guess like that's something we can consider as an enhancement. We can handle for scheduling mechanism like implicit scheduling control based on capabilities. But that's not the focus of this discussion, so I'll leave this for post discussion if we see it. But no explicit swap limit has like limited interactions. It will not swap unless explicitly specified. For disabling, I would see that like users would be able to set swap limit as 0, which would set the swap max C group control on the pod. I think like I could pause here because I don't see the screen here. Maybe let's discuss some more and go forward that. Oh, I see a hands up. Sorry. Go ahead, Sergey.
Yeah, I have a hand. I think you started with assumptions that people will have these two different modes, and it may be valid assumption. I'm not convinced either way right now. My question will be like, if we go with two modes, I really want to cover scenarios when people want to disable swap for specific pod. If they will need to disable it different ways in different modes, it will be quite toilsome for them and cumbersome to apply any OPA policy or whatever. So ideally, it just should be somehow unified, or some unified API should be enabled. And then if we truly believe that it's separate modes, is there any reason for customers to use previous mode? Like, I think new mode is so much more powerful than like limited swaps with calculated limits may not be like, what would be true benefits of using limited swap, and like will every customer just prefer new mode out of the box? That's basically my question.
Sure.
Yeah, because new mode it made so many problems.
Right. Let me maybe like take the first question to the second. Like, when do we see limited swap would be used? Would everybody start using the workload swap? I think that's use case specific. Consider like a CI/CD pipeline where I cannot specify or cannot intend to specify like the individual swap limits per workload. The best option I would probably just go with would be like said limited swap, where any swap as available can be best utilized. I think that like we cannot fit on the use cases. I think it's up to the Kubernetes user to see it. But limited swap existing users who are happy with it can still be okay with just continuing to use them. They don't need to force migrate into workload swap if existing use cases just seem to be happy with that, right?
Yeah, it's not the question whether they will continue using it. It's a question of if you have a choice between two, is there any reason to choose limited swap?
Would be that I don't want to specify explicit swap limits because I'm not aware how much swap is best fitting for the workload. It can be like small burstables that can best make use of swap as possible.
Okay, and then the same question will be like, sorry, Mural, I just continue on that. The same question will be, if there are customers like that, why wouldn't they have the same requirement for new mode when some pods want some exact swap and some pods just want whatever you can offer?
If I get your question correctly, is it that like why can't we have like a default limit for the workload specific mode and make the users allowed to set limits sometimes and not set limits sometimes?
Yeah, basically,
I think that would be.
Yeah, I really want to the document to cover those assumptions. Like you're making an assumption that is may or may not be valid, and I'm just trying to play it out to understand whether users will even want to choose one or another, like when they will want to choose one or another. This table attempts to do that, but I think it's not going to enough details.
Okay. Yeah, I think that like I could follow up on the assumptions more. I think that like I captured some of the assumptions. I maybe discuss that in detail further in the doc. Please feel free to add comments and be able to discuss in detail further. Hamilton?
Hey, thanks for starting this. So what about scheduling? Like, is this going to be treated as a first class scheduling construct? I read something around node capabilities, but don't have enough details.
Yeah, definitely. Thank you. Yeah. So I don't see that users specifying request for swap and scheduling based on swap as a resource is the best design for Kubernetes. This is intentional because like it is not a consumable resource by the workload. Upright, like users can like select X amount of swap, and if not that much amount of swap is available, don't schedule them on the node, because like what will likely happen is that like as long as like the node is satisfying all the other resources, just because swap is not available, the node will be underutilized. What I am coming at is that swap is a contingent resource. It will be utilized only when there is node pressure. So even when it is an allocatable or when it was like taken by many pod, it will actually be free. Node will not even have any swap utilization on it. So that's not like a good approach to think about it. There is another part of the scheduling aspect, which is placement control. I think that like discuss this here. Should swap limit 0? Does it mean like user intended to not place it on a swap enabled node, or did the user intended to place it on the node and set it as 0? Right. That's the aspect I think that like I see it as a scheduling problem. But I think that like solving this within limit is overloading the API. Limit explicitly says that like I'm okay to be placed on the node that is swap enabled as long as I'm set the calculated limit as 0. If the user has like node isolation concerns, they could use like other node isolation mechanisms like placement control, like taint to select the nodes on specific workloads on specific nodes, or labels as we discussed for in NFT use cases. The implicit scheduling, as I see it, is that when, let me go to this, yeah. Node capabilities could be for mode discovery, like when limit is set. Now we can easily, when workload controlled swap is available, we can easily have an understanding that like user explicitly have a limit set, so user intended to group them like place these workloads on workload controlled swap mode. So we can make that choice for the user. Kubernetes can implicitly have an understanding that, like with explicit limit set, these belong to the workload controlled swap mode. That's what I see as the placement solution we can have with node capabilities.
What about, like, say if I have a guaranteed pod, which I know is going to have spikes, and I'm going to give it some swap so it can handle those spikes, but most of the time it's going to be under, and I really want to protect this pod. Now, if a node is overcommitted in terms of swap, that may put that workload at risk. I'm just calling out a scenario. You don't need to answer that. I'm just thinking out loud.
Yeah, that's great. I think that like we want to have one firm stance. Either user can have swap or they cannot have swap. Limit explicitly says that like if you want swap, you specify a positive integer limit that would allow the workload to like utilize swap. User can choose to disable swap by setting a 0 guaranteed. We don't see that to be based on swap home protection, like can be enabled on certain time. I don't think that like that is a good idea for guaranteed. Yeah, it's not that like you can have guaranteed, but only on the time of swap is needed, you can start tapping into tap. Yeah.
I don't want to hold this. Thanks, Ajay. Kevin.
Yeah, I was just curious on, so like with the scheduling conversation, like what I'm thinking about for like swap limits, is there anything that's like people know that like you specified too many pods with swap on a node, and even if it's not being used, like the limits are exceeding the swap memory on that node. And I'm wondering, like, if we don't have that in scheduling, how do we know, like, if people are overcommitting swap on that node?
That's the question. I think that like one I think it's breaking. I'm not sure like if there's my speaker as a mic, someone's mic. Okay. So your question is that like how can we allow overcommit safely? Is that like a good summarization of your question?
Yeah, or just like if every pod, let's pretend you have a single node and all the pods have swap, how do you know like you have exceeded the actual physical memory of swap by limits, even though if it's not being used? Like, is there, I don't know if the kernel like has like will not let you set, like, because you're saying limits would be like, I don't know what kind of validation there is to say like, you know, this limit is more than what I actually allow for my swap node. And then also if I have like 100 pods, they're all requesting swap limits, or do they exceed the physical capacity of the possible capacity of swap memory on the node?
Gotcha.
Does that make sense?
Yeah, that makes sense. So the idea is that like we are allowing to overcommit, like the sum of all the swap limits can exceed the swap capacity for two reasons. Swap is a configurable resource on the node. More swap capacity can be added. So if the Kubernetes user can configure alerts on like swap utilization that we have today, that it's exceeding 80% capacity, and they can like grow their swap if needed. And the second aspect is that like if the swap limit is fully utilized, if the full capacity is utilized, it's not going to have like, for example, like just like hitting a memory limit, it's not going to be immediately booted out by the kernel or something. It's just that the swap is no more room for the workload to grow because like swap capacity is full. So it would just not use swap. So I think it is still a safe position for Kubernetes workloads to be there. I think that like having better alerting mechanisms and having allowing the users to specify limits and overcommit will go to better swap utilization story on Kubernetes and give better protection than having a reservation on like basically like it should be not like AWS should be within that. It will have underutilization of node. I think the users will prefer the former than the later.
Yeah, I guess I'm just concerned on more like if both my memory is filled up and then people keep using swap, all of it, and like you hit a point where like the node, I mean, if I guess the node has issues, the ohm killer would probably step in at a certain point. But like if you overcommit and you're in this case forever, like you're at memory pressure and you're also overcommitted all the swap. I don't like that. To me seems like it could be a potential bad like behavior on the node. And I'm wondering like with users setting limits, like it seems like I don't necessarily know if there's any protection to avoid that.
I don't still see what sort of protection that Kubernetes should have. Is it like, do you see that like, okay, only this much overcommitting should be possible? Do you imagine something like that?
Well, I guess like sorry, it's wrong if I looked at this, but like usually like for memory, we would have like a node like capacity or allocatable, right? Like we would know like whether or not like you have too much memory, so then that node is full. Like for me, like what I don't understand with not having this swap, is there ever a place like, will we know, like have I overcommitted swap and I can't accept another pod that is requesting swap, right? And that's kind of what I was wondering. Like without the scheduling decision, I don't know. Like, can we handle that?
I don't see that we will be handling that. My KEP is focusing on like swap is not a schedulable resource, like on X amount of swap is needed to be able to place on the node. I think that like if that is a requirement, this we can plan it later. But I see that like having swap as a schedulable resource would mean that when swap is not available, but node has other workload satisfying resources like CPU and memory, it cannot still be placed on the node because swap is not utilized because it's not memory pressure. Memory and CPU are available. However, because swap cannot be overcommitted, it is not placed on the node. That will have under utilization story on the node. I think that like even without swap, workload should be still able to run on the node because it's not a consumable resource is where my thinking is.
Yeah, I mean that makes sense. Yeah, it's just, yeah, my that's the only concern I have with not. Like I don't actually. I agree. I agree with you that I don't know if it makes sense for swap to be a schedulable resource, but I do wonder if there's some kind of observability we would need to know, like whether or not people have overcommitted to swap, and there's a potential that like, you know, with if you sum all the swap limits on the pods on this node, are you actually exceeding the swap capacity? And like that, like that's at least because to me, like that's, I wasn't too sure if your proposal handles that.
And that makes sense. I think that we should definitely improve the observability story. But yeah, this is like something evolving. Like overcommitting should be possible is where I see fitting. But I think like how we should handle when the overcapacity, if the overcommitting limits exceed the capacity, should we have an explicit condition or things like that? Maybe we should definitely discuss more on that.
And I guess, do you want to put comment? I can put a comment on this doc or for that, or do you want comments on this or?
Yeah, please. I just thought to get early feedback. Please add your comments. I will explore more on the talk and continue the discussions. I think Itamar is not here today. I also reached out to them over Slack. We could continue the after comments and after discussions on the follow-up meeting. If there isn't any, no, please find time to add comments offline at the talk.
Thank you, AJ. Was there any other thoughts on swap? It doesn't look like we have any other.
I had some, but they all got swapped. Sorry for.
Exactly. All right. If there is no other notes, then we can adjourn for this week.
All right. Thanks, folks.
Thanks.
Thank you, everyone.
Start with release highlights in the beginning of agenda. Thank you.
Thank you. Bye-bye.